So I don't know if you guys remember from yesterday, but I had an example where here was my coordinate plane, and I had two lines crossing on it, and you had to tell me where they intersect. And it was kind of a weird number. So today I'm going to ask that same question, where, if 1, 2, 3, 1, 2, 3, where does that intersect? And you might say, well, it kind of looks like, oops, let me back that up a bit. Kind of looks like it might be at, like, say, 1 and then 2.3, we'll say. And this is always fun because I always say, wrong! How could you be so silly and uninformed and uneducated? Clearly, that is the point 1.92785 and 2.46799328. Are you blind? Could you not see that on your own? And like everyone laughs and it's a good time, right? But seriously, when it comes to graphing, you kind of just have to either assume it's on the points or give your best guess. And that's just not always good enough. Sometimes I need to know exactly where the two equations are the same. So that's where we're going to start doing this algebraically. We're going to learn 4 ways to do it algebraically. Graphing, we did graphing already. Algebraically, it would be substitution, elimination. We'll use inverse matrices, and we'll also use Cramer's rule. So we'll get to that in the later part of this chapter. For today, substitution is what we're going to do. Basically, we're going to take one equation, substitute it inside the other equation, and that's why we call it substitution. So you can kind of see there the book explanation of what to do. You guys know me. I like to just do examples. So here's what you're going to do. Step 1. One equation, or one of the equations. Whew, that was a weird, there we go. One of the equations must equal a variable. Now it doesn't matter which variable. You can do x, you can do y. It doesn't matter, as long as it's y equals or x equals for one of the equations. And then here's what I'm going to do. So like on the first one, I see the y equals 4x minus 6. I'm going to take this part that it equals and substitute it for y. Much like, think about this for a minute, if I told you y, if I told you y equals 3, you'd say, oh, okay, take this 3, plug it in for y, and solve. That's all you're doing. It's just instead of this time y equaling a number, it equals a whole mess of stuff, but you still plug it in the exact same. 5x plus 3, don't write y, instead write what y equals, and y equals 4x minus 6. Holy cow, that looks longer and worse than the first, what we had to begin with. Why was that helpful? Well, we got rid of a variable, so we no longer have a 2-variable problem to solve. We just have one variable. Now it's just a really fancy multi-step equation. Check it out. First I'll distribute. 3 times 4x is 12x, and 3 times negative 6 is negative 18. And if I combine like terms, they're on the same side of the equal sign, so I can just combine them to get 17x minus 18 equals negative 1. I think I'll add 18 to both sides. That way I have just 17x left over on one side. And it looks like a 17 on the other. 17 divided by 17 is 1. Now, here's a problem. Yesterday, if you noticed, all of my answers were in point form. All of your answers today are going to be in point form. But so far, I only have an x. Here's what you need to do. Take this x, plug it back in to one of the top equations. It doesn't matter which equation you use on top. Both of them will give you the same answer. As a general rule, I like to use the one that says either y equals or x equals because, I don't know, it just seems like it takes less time to solve. So y equals 4, parentheses, x equals 1, so plug in a 1. 4 times 1 is 4, and 4 minus 6 is negative 2. So my answer as a point is 1, negative 2. That's all you do, folks. Now there are a couple exceptions to the rule here, so I'm going to start here with 2a. Watch out, sometimes you won't already have a variable that equals itself. So what I'm going to do is decide which equation do I think looks easier to solve so that I have a variable by itself. I think it's going to be the bottom one. I'm going to try adding 3x. Y equals 3x minus 13. That should be pretty easy to take and plug in for y. Okay, I'm not going to finish that one because I want to do some where the answers are weird. Let's see. I think these two will be weird answers for us, so that's good. I'm going to take this 2x minus 3. It does look like the y is already by itself. And I plug it in for y. 2x minus, parentheses, 2x minus 3. And the whole thing equals 8. I'm going to distribute the negative sign, basically multiplying by a -1. 2x minus 2x plus 3 equals 8. And 2x minus 2x cancels. Oh, whoa, watch out. I don't have any variables left, and all I have is 3 equals 8. I don't think I did any of my math wrong, but I don't think 3 is ever going to equal 8. There is no world where I can say 3 equals 8 and have that be a true statement. Well, what you have here is actually one line that looks like this and one line that looks like this. This answer is no solution. Um, 3b, I will maybe let you try that one, but I will tell you, if you get down to where it's like 4 equals 4 or 20 equals 20, right? It equals itself. 20 will always equal 20 and 4 will always equal 4. So in this case, the answer is infinite solutions. We're going to talk in class about the difference between infinite solutions and all reals, but there it is.